Yeah.
हाय हेलो एवरीवन, मेरा प्यारा बच्चा लोग वॉरियर्स कैसे सब जल्दी बता we have an amazing session waiting for you, right? So in today, in our third lecture of gravitation, we'll be talking about some of the important and very new concept which you even won't be finding the concepts in NCERT. But it is so much important for understanding this particular chapter and doing many problems for your board examination and JE, which is electric field. Sorry, it's not electric field, right? Because I always be taking for 12th standard, right? So it is for yes, the gravitational field we'll be mainly discussing in today's session. So jaldi se jaldi fatafat tell me, am I audible and visible to everyone in this classroom? Jaldi various बता दे मुझे. Hi Dr. Aarti, hi Harsh, hi Study, hi Destroyer, Sonam, hi Archie, Myara, good evening, Sugamana good evening Palak, Harsh, Destroyer, सब कैसे है? जल्दी बता. मेरा पूरा वैरियर्स पूरा का पूरा वैरियर्स लोग, आप सब लोग कैसे? मैं तो बिल्कुल बढ़िया. I hope you can see that from my smile. I'm so happy. Thank you so much everyone for letting me know that I am audible and visible to everyone in the classroom. Hi Himanshi. Okay, so a big hi to everyone who are seeing me for the very first time. This is your Ameer Bhaiya, physics educator at Unacademy, and I hope you all can see a bit of introduction about myself. है ना? I have an experience of more than 3.5 years in the field of teaching. I'm a BTech graduate from NIT Calicut, and I thought and mentored so many students, and they are doing so good in their life. This is all about me. But I'll tell you once again in today's session, which is the third lecture of gravitation. Mainly the topic of our discussion is gravitational field. It is an important topic for your board examination and also for JE and also for NEET. Don't miss the session. Start and be with me till the end of the session. है ना? I hope everyone will be there. How many of you will be there till the end of the session? Jaldi bata. Everyone, right? Okay, very good. So let us proceed. This is the schedule for this particular week. As you can see here, on 5th of October, we are here with the topic of gravitational field and potential. Okay, so usually Wednesdays we won't be having any classes, and Thursday and Friday I won't be there due to some personal reasons. The next class will be on 11th of October, which is gravitational potential and energy we'll be discussing. Fine. Okay, yes. Moving on. You know that amazing educators are there with Unacademy Class 11th and 12th YouTube channel, right? And I know that you don't want to miss any of the live classes happening from these educators. And if you want to get the notifications and alerts at the right time whenever a live class is going on, do come and join this Telegram channel. I hope you all can see the link, है ना? जल्दी से फटाफट आ जाइए सब लोग. Then, don't you think it'll be an amazing decision that you can take to be a part of Unacademy family and to start learning with us? I think that is one of the best options you can take at the right moment. And if you want to start learning with Unacademy for completely free, here we are giving you a chance, because the scholarship test is going to happen on 10th of October at 1 p.m. And if you get a very good score, scholarship will be given to you and you can even learn with Unacademy for free. Wow, that's an amazing thing, I suppose. है ना बच्चा लोग? Then I'll talk about why Unacademy subscription is so much important. Then we'll start with our classes. ठीक है? Now, listen to me. We all educators will be telling you, right, to be a part of Unacademy subscription. But you know that nowadays everything is available for free in YouTube. So what's make it special to be a part of Unacademy subscription? I'll just tell you, or I'll give you some reasons for you, right? The first thing, we all educators will be teaching in the Unacademy subscription with a proper schedule targeting board examination, JE and the NEET examination. And whenever we teach in the subscription platform, we'll make sure that everything is in super order, okay? And you can keep track of all the topic that is being taught in the classroom, okay? And once everything comes in order, what happens? Yes, the entire process of learning will become super simple and you can learn a lot, okay? And if entire learning process becomes simple, yes, you can go and write your examination with a peace mind and get the amazing mark which you are supposed to get from there. Then, top educators of the country who is already having a very good experience with the educational field is already there with an Unacademy subscription platform. So if you start learning with them, they'll be telling you what are the kind of examination question that is going to come. What is the examination pattern going to be? You just want to follow them. And if you just follow them, you will be ending up in the colleges whichever you are desiring. Then study materials will be given to you, practice test and live test series which will be happening every week will make you super confident and will bring out the best from every one of you. For this features to enjoy, you should be going for the Plus subscription, and as you can see, for 1 minute bacha log. For 9 months of subscription, it will cost you 1444 per month. And do you actually need to pay this much? No. Kyun? Because Ameer Bhaiya hai na. And here is your code AMB10. Use this as a referral code whenever you make a subscription and get 10% of discount. So this is for Plus subscription. ठीक है. एक और है. One more is there, which is iconic subscription. You will get all the features of Plus subscription here, and extra some features will also be there, such as a personal mentor, someone to help you with your academic activities 24/7. He'll be telling you what to study, what is your study strategy should be. For everything, that person will be there. Live doubt solving classes will be there. Okay. Then weekly reports will be given to you. For all these amazing and super great and cool features, you should be going for iconic. And for 9 months of iconic subscription, it will cost you 2556. And you know that you don't have to pay that much amount of money also again, because you have the referral code with you, AMB10. Use this code of AMB10 and get 10% of discount and make an amazing and wise decision and start learning with Unacademy right now. 2 reasons are there. The first reason is my crash course, okay, with Anurag Thagi sir, Pranjay sir, Vivek Gupta sir, Nikki ma'am, okay, is going to start on 11th of October. You can come and join. It's a crash course which will help you to get an amazing mark and to prepare in the best way possible for your upcoming term 1 examination. Okay, then that's it. This is all about Unacademy and me. Now it's all about the physics and all my various. Jaldi se jaldi fatafat bol de. Are you all ready to start learning this particular topic? Jaldi. Devika, Archie, Saurav, Avishka, Destroyer, jaldi bol de. And do let me know that the energy in the classroom is still super duper high and you all are waiting for the classes to get started. Jaldi. And whenever you say yes, do remember that it is your responsibility to keep the chat box on, which means whenever I ask you questions, the answer should be there. Good evening, good evening. Yes, everyone, let's start questions. Super duper ready. Okay, very good, very good. So, we'll start today's session by doing a question from yesterday's topic. Ready, Anna? So, everyone start doing and do let me know which is the option. I'll also help you, those who are having little trouble. So, jaldi se, jaldi batao. Which all were the topics we were discussing in yesterday's class? Main topic of discussion was the acceleration due to gravity. What was the formula? Those who forgot, I'll just help you remember. Right? The formula for acceleration due to gravity was gm divided by r square on the surface of the earth. And acceleration due to gravity will be different for different planets. Why? Because mass of that planet and radius of that planet has to be used whenever you find out the acceleration due to gravity on that specific planet. Right? Okay. Then there are 4 different reasons which we have learned that will be the reason for the change of acceleration due to gravity. One by one. One is the shape of the earth. Hai na? Because of the shape of the earth, the radius will be changing, because at the polar regions, what will be happening? The radius is lesser. Hai na? So, when the radius is lesser, the acceleration due to gravity at the polar regions will be more compared to the equatorial regions. Why? Because earth is having a geoidal shape. Hai na? Aise. And radius at the equator is more compared to what? The radius at the polar region. Ab sabko pata hai. This is radius of equator, this is radius of polar. So this is the first thing. Then second thing is, because of the height, which means if the altitude from the surface of the earth changes, right, the value for acceleration due to gravity will also be changing. Formula of acceleration due to gravity at a height h, gm divided by r plus h the whole square. And we have learned one more formula, and there is a condition also for using that formula. What was that? If the value of h was very small compared to the radius of Earth, gravitation or acceleration due to gravity at a height h is equal to g into 1 minus 2h by r. है या नहीं? है या नहीं? ये भी पढ़ लिया. Then acceleration due to gravity at a depth d. Formula g into 1 minus d by r. Then acceleration due to gravity because of rotation with an angular velocity of omega. Formula g minus r omega square cos square lambda. What was lambda? Lambda क्या था? अरे भाई हाँ. What was lambda? Lambda was the angle made by the radius to the point with the equator. है ना? So these were the topics which we have learned in yesterday's class. I think you all came to the class by doing the entire revision and doing some extra problems. Okay, so those who are absent, please note it down and watch yesterday's classroom after the session. ठीक है? Now, पहले we'll do a questions from yesterday's topic. Then we'll start with the new topic of today's class. Jaldi, it's an amazing question. Let's see. A man can jump to a height of 1.5 meter on a planet A. Okay, what is the height he may be able to jump on another planet whose density and radius are respectively 1/4, which means 1/4. What the density will be 1/4 of the density of the Earth and 1/3 that of the planet A. How will we do this? For this, you should be having a very good understanding of the chapter of work for energy or work energy theorem. Okay, let's see. We have the planet A, and this is the surface of the planet A. Now, from the surface, the man is going to jump. If he is jumping, what will he be associated with? He will be associated with a velocity and he will be associated with a kinetic energy. What will be the kinetic energy? If he is jumping with a velocity of u, half mu square. है ना? And with this velocity, the particle moves up. As the particle moves up, हम सबको पता है, velocity decreases, and when it reaches to some height, the velocity will become 0 at its maximum height. And what you can say is, the kinetic energy has completely converted into what? The potential energy. Those who know this particular concept, this question is done. So, during the process of jumping, what is happening? The kinetic energy associated with the boy is getting converted into mgh. This is the case. Okay. The question is, if he is able to jump to a height of 1.5 meter, what will be the height to which the same person can jump with the same velocity in a different planet? Let's see. हमारा साथ, we have another planet, right? The density of this is equal to 1/4 the density of the planet A, 1/4, and the radius r dash is equal to 1/3 the radius of the planet A. How to do this? Same concept. देख ले. From here, the person jumps. What will be associated? He will be associated with the same kinetic energy of half mu square. Because it's the same person, it will be with the same force he will be jumping, so he will be associated with the same velocity and he will be associated with the same kinetic energy. ठीक है? And as the person moves up, as we all know, velocity decreases, and at some height, this kinetic energy will be converted into potential energy m. This is different planet, so it will be associated with a different g dash, and it will be moving to a different height also, which we don't know, h dash. This is what we want to find out. इधर तक समझ में आ गया? And I think many of you might have given the answers also. ठीक है. Now, how can I find out this g dash in terms of g according to the information given? This is another task. कैसे करेगा? कैसे करेगा? And I think I have told you how to include this density in the equation of g. Those who do remember that might have already given the answer in the chat box. I'll be looking into the chat box after I complete this. Okay, so everyone be prepared there. G का value, g m divided by r square. Actually, I have did this in yesterday's class, but still, whoever was absent, I'll do it once again. This is G by R square. Mass is equal to density rho into volume 4 by 3 pi R cube. Yes or no? Yes. R cube by R square, R will be remaining. So what happens? 4 by 3 pi, 4 by 3 pi G rho R. This will be the formula for acceleration due to gravity in terms of density and radius. Bas. So can I substitute it here for G dash? Kar sakta hai? Jaldi. This will be equal to M. What will be G dash? 4 by 3 pi G, dekh le, 4 by 3 pi G. What is the density in the planet B? Rho by 4. Rho by 4 into radius. What is the radius of the planet B? 1/3 of the initial radius. है ना? Into this is G dash. What is remaining is H dash. हो गया बस हो गया और कुछ नहीं, कर दिया. देख ले. This is equal to M into, can you tell me 4 by 3 pi G rho R, 4 by 3 pi G rho R will be equal to our actual G, initial G of the planet A. So this is M G, right? And what is remaining? 4 3s are 12 multiplied by H dash. Bas ho gaya. Done. If you have got till here and if you have understood the concepts till here, done और कुछ नहीं. What is left to be found out? H dash. कैसे करेगा? देख ले. Left hand side half mu square. Initial part of the formula half mu square, right? Left hand side is the same, है ना? So right hand side will also be the same. Shall I write it? Shall I write mg by 12 into h dash as mgh? कर सकता है. और क्या सर? बिल्कुल mgh. Done. mg will cancel. So h dash will be equal to, the new h is equal to, ये 12 है ना, ऊपर जाएगा, multiplied by h. 12 times h का value 1.5 और 3 by 2. बस हो गया तो हो गया, उत्तर भी मिल गया. Anybody gave me the answer for this? Let me see. अरे बाप रे, many of you have given the answer. I can see Vandana with 80 meter. Miara has given the answer. अरे बाप रे, Himanshi, Preeti, अरे then Shreya, Palak, Sonam, Sanskriti. अरे बाप रे. Seems like everyone is here by completely preparing. Tell me how many of you came to the class after revising this topic? Very good. I know that. I'm actually happy and I'm also too excited. Seems like everyone is here by completely preparing this topic. Yes, Shreya, very good. Tell me how many of you did the revision, because I'm too excited to see this, that everybody have got the answer before me. Mohit did the revision. Sonam, अरे मुझे हिंदी तो नहीं पता है ना, तो कैसे? How can I speak in Hindi? Yes, see Harsh, very good. So Mohit also, Sachin. So I can see many of you came to the classroom by completely doing the revision. That is one simple amazing thing you all did. Bilkul badhiya. So shall we proceed? Right? Yes, with a smile. और क्या sir, बिल्कुल. Okay, a new topic which is gravitational field and the field strength. शुरू करें. Okay, I want everyone's concentration here and I want every one of you to take a notebook and a pen and start writing the entire concept. देख ले. We have a pointed mass of capital M. Okay, can you see the space around this capital M? Can you all see? Right. Wherever in this particular space I keep another mass of small m, this small m will be experiencing an influence on it. Matlab, this small m will be experiencing a force because of this capital M. है ना? So the gravitational field is defined as the space around a given charge where its influence can be felt by other masses is simply called as gravitational field. What is gravitational field? It is very important. It is the space around a given mass where its influence can be felt by other masses is simply called as gravitational field. So I'll write in short form, it is the space around a given charge. Note it down. Okay, done. Now देखले, if I keep this mass m at a very long distance and if I take another mass and keep it close to it, which mass can experience a larger force? Obviously the mass which is very close to the capital M, है ना? Which means the strength of the gravitational field is different at different points. So how can I find out the gravitational field strength at different points? ये देख ले. What I'm going to do? I'm going to find out the gravitational field strength at different points. Okay. For this particular thing, what you have to do is, wherever you want to find out the strength of the gravitational field, let's say I want to find the gravitational field strength at this point. What do you have to do? Keep a 1 kilogram mass there, okay, and find out the force this 1 kilogram mass experiences because of that capital M, and that itself is simply defined as what? The gravitational field strength, which is represented with the letter E, and it is also a vector. Why vector? Array, the gravitational field strength is the force experienced by a unit mass. Doesn't force have a direction? Yes. What will be the direction of the force? Attractive. So obviously, whatever is the direction of the force this 1 kilogram experiences, the same will be the direction of gravitational field strength. Okay, done. Okay, now the only thing what is left is finding an equation for gravitational field strength. ठीक है? Okay, once again. Why we are here? हम क्या कर रहे थे? What we were doing? We were trying to find out the value of E, which is the gravitational field strength at this particular point, and we know that it is a it is a force per unit mass. It is not necessary that all the time we will be having a 1 kilogram body in order to measure the gravitational field strength at each and every point. So what will we do is, to measure the gravitational field strength, whatever is the mass we have, we will keep it there and find out the force it experiences. How much will be the force it experiences? Let me write it here. G, capital M, small m divided by, if the distance is r square. But you have to know that this is a force experienced by a mass of capital M. And what was a gravitational field? That is the force experienced by a unit mass. This is a force experienced by a mass of m, and what we want to find out is a gravitational field. It is a force experienced per unit mass. F by m is actually the gravitational field. What will be F by m? G mm by r square by m. G m divided by r square. For a pointed mass of capital M, okay, the value of gravitational field at a distance of r from it is given by G m divided by r square, and it's a vector. What will be the direction? We know that it is the force it experiences. What is the force experienced by this mass? We know that gravitational force is always an attractive force, so it will be attracted toward the capital M. बस इतना ही है regarding gravitational field strength. But let me tell you, this is one of the important topic. This is one of the important topic, okay, and you all have to learn it, because the reason for you or for me to tell that this particular chapter is very important is because in 12th standard you will be learning about electrostatic field. If you understand this particular topic from here, and if you go to that particular class of 12th standard where electrostatic field will be taught, अच्छे से आपको सब आ जाएगा, which means you will be understanding those concepts in an amazing way. Okay, so is it clear? सबको समझ में आ गया? जल्दी बोल दे. So do note this. What is gravitational field? It is a space. And what is gravitational field strength? Okay, gravitational field strength is a force experienced by a unit mass. And for a pointed mass, the formula for gravitational field E is equal to gm by r square. It's a vector quantity, right? And what will be its direction? It will be the direction of force experienced by the unit mass, which means it will be an attractive force. Bus, note it down. Sab, tell me, bata de. Do you remember this particular formula of gm by r square? Yeah, gm by r square, have you seen this? Have you ever seen this gm by r square formula? Arey, wasn't this a formula for acceleration due to gravity? Bhul gaya? Wasn't this a formula for acceleration due to gravity, gm by r square? And now we are learning another concept of gravitational field strength with the same formula of gm by r square. ये क्या हो रहा है इधर? What is happening, sir? Are they the same thing? No. Though the equation is same, okay, they are talking about entirely different thing. I'll tell you, it is just like twin kids. Okay, so when there is identical twins, okay, they will be looking alike. But are these two people completely similar? No. The person A and the person B will be looking alike, but it is not necessary that their behavior, what they do, what they love has to be same. There will be different people. They are two different people. है ना? Similarly, though the equation for acceleration due to gravity and the gravitational field are one and the same, or they look the same, they are not the same. They are having different concept completely. है ना? Acceleration due to gravity talk about the acceleration the body has whenever a mass is being attracted, and this talks about the force per unit mass, as you can see it here. Okay, so understand the difference between them and get it and note it down. So we are proceeding. We are going to proceed further. Okay, let's do a question. Okay, a chotu sa problem. Actually, it's a direct formula also and a direct question also, but I want you to understand this particular concept. That's why we have made the simple question. A particle of mass 20 gram experiences a gravitational force of 4 Newton along the positive x direction. Okay, find the gravitational field at the point. It is a basic question, but by doing this basic questions, the concept about this gravitational field will be clear to you. Dekh le. Gravitational field E vector is defined as the force experienced by a unit mass, F vector divided by m. Yes or no? The force is given as how much? 4 Newton. In which direction? Along positive x direction. So 4 I cap divided by, what is the mass? 20 gram. So 20 into 10 power minus 3. 4 by 2 is 2. How many zeros more? 2 zeros more. What is the direction? I cap. I cap matlab along positive x axis. So हमारा उत्तर हो जाएगा option B. Understood how to deal with, obviously it's a simple question, I do agree with you, but understood the conceptual part now, how to deal with each and everything. When things are given, how will you find the unknown, how to choose the direction. If everything is clear, you can note it down and mark the option as B. Raviraj, very good, it's option B. Myara, okay, yes Palak, very good, बढ़िया बात है. Okay, Hellish World is asking, isn't F by m the acceleration? 5 minutes before I have explained you. Okay, 5 minutes before I have explained you, though it looks the same, the conceptual part is totally different, right? Okay, so please watch 5 minutes before, you will understand why the equation is same, but the conceptual part of acceleration due to gravity and this concept of a gravitational field is different. So block 1 student here who he is disturbing the entire classroom. ये कौन है? ये डॉब भैया है? Okay, so डॉब भैया को कर दिया. Saloni got super angry, है ना? Saloni is like, अब तो मिल जाएगा अरे देख ले, ये तो ठीक है, हाँ कोई गड़बड़ नहीं, जाएगा हम, और क्या सर, बिल्कुल। Okay, now gravitational field due to a uniform solid sphere. But before going to solid sphere, first we'll be talking about a spherical shell. ये spherical shell क्या होता है, and what is the difference between a spherical shell and a solid sphere? One simple thing. Which color do you like? White color is good on black, है ना? Black and white movies. So we have our earth, let's say, or let's say this is not earth. Okay, this is a hollow sphere. Okay, we'll also call it as spherical shell. What is the meaning of the spherical shell? Matlab, inside nothing is there, the entire mass of the body is being distributed over its surface area. This is called as hollow sphere. Okay, now the question is, or what we have to derive from here is the value of E, which is the gravitational field at different points because of this hollow sphere. Shall we do it one by one? For a point from the center which is at a distance of r, what is the formula for E, which is the gravitational field, force divided by mass, which means if you are keeping a mass here, find out the force experienced by this mass because of this hollow sphere. How much is it? Everyone knows, G m divided by r square. This is force divided by mass, smaller, cancel हो जाएगा, gm by r square. No problem at all, because we already know this particular equation, है it is gm by r square, nothing about. Now let's say if I am taking the point on the surface of this hollow sphere, अब हो जाएगा gm divided by, instead of small r, we will be taking the radius of it, gm by capital R square. ये भी हो गया. Okay, इन दोनों में कोई गड़बड़ नहीं, nobody will be having any issues and nobody will be asking, sir ऐसे क्यों? But now when I say, so many will be asking, if I have a point inside. Now if I ask you, what is the value for E, which is the gravitational field, I will be telling with full of confidence, इसका value तो 0 है. Now how many of you are going to ask me, sir why, क्यों? Why the value of gravitational field for an inside point is 0? I'll explain. Gravitational field का formula, force experienced per unit mass, right? Tell me what will be the force experienced by, let's say if I'm keeping a mass m here, it will be 0. Why? Because देख ले, this is a hollow sphere. Inside this particular hollow part, कोई mass नहीं है. No mass is there to provide a force on this छोटू m. So if no force is there, will it be attracted? नहीं. So force will be 0. So this gravitational field will also be 0. One way of explanation, right? Because you cannot find any mass inside this other than this छोटू m to get attracted to. If there is no mass, no force, E0. Another way, I know that many of you will be having the doubt, sir ठीक है, अंदर तो नहीं है, there is no mass inside this hollow spherical part, फिर भी isn't the mass surrounded by this capital M of a hollow sphere? Yes, it is surrounded. But what happens is, this mass will be entirely attracted to all the direction, ऐसे, 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 ऐसे. Now I'm going to tell that this force will be converted, or the net force acting on this mass will be equal to 0 because of the mass surrounding it. Sir, ऐसे क्यों? It is not symmetrically placed. The mass is not symmetrically placed. How the net force can be 0? One way of explanation. You know that this much of mass you take, right? This much of mass is very close to this small m. Matlab, if the distance is less, right, the force it can provide is large. Isn't the equation for force? Yes, if the distance is less to this much of masses, right, but its mass is also less. So distance is less, which will be giving a large force, but it will be compensated by the small amount of mass here. Okay. and the remaining mass, this mass, okay, this mass of this hollow sphere, though there is a large mass here available, but to this point the distance is larger. So the large mass which could have given a larger force will be compensated by the larger distance. So distance large ho jayega, force will be decreased. So these two forces will be compensated because of the value of masses and distances, and the net force will be 0. So we can say that the value for gravitational field inside this hollow sphere will be equal to 0. It's very important. Jaldi se jaldi note kar le. Okay, what all you have to note? The value for gravitational field for an outside point is gm by r square, first thing. Then on the surface it is gm by capital R square. Then inside it will be equal to 0. Okay. Noted. Noted, Preeti. Very good, very good. Very important. I hope you all know whenever you come to Ameer Bhaiya's class, क्या लेना है आपको? एक पेन और पेपर और कुछ नहीं, and थोड़ा मोबाइल का इंटरनेट भी अच्छा ही है. Written, very good, very good. Note ചെയ്തു sir. എല്ലാം വ്യക്തം സലോണി. बढ़िया, बढ़िया, बढ़िया. Okay. So let us proceed. Okay, so we have done with the spherical shell. Shell matlab inside there is no mass, है ना? So for an inside point, the value for E, which is the gravitational field, will be 0. So I hope you can see a graph that is being plotted between what and what? Between the gravitational field and the distance from the center. You know that if you start the distance from the center till it reaches the surface, what will be the value for E? It will be 0. And the moment it reaches on the surface, it will be having a value of, what will be the value of E? Gm divided by r square. So at a distance of capital R, right, you will be having a value of E equal to Gm by r square. Okay. And if you again move away from the surface, the value of E will be Gm by small r square. है ना? Which means as the distance increases, now away from the center, the value of E will be decreasing. Q, they are inversely proportional. Okay. This is a graph 4. किसका graph है ये? Yes, very good. I hope you all are telling the answer inside your mind. Yes, this is a graph 4. The gravitational field and the distance from the center till it reaches the surface, it will be 0. Keep this in your mind. Very important. Okay. So let's see, do we have any questions based on this? No, the questions are based on solid spherical part. Now I hope finding out the value for a gravitational field on a hollow sphere is completed and everybody got the idea. है ना? I hope, can you all give me a smile like this? If you all can have a smile on your faces after listening to the concept, it simply means, what does it mean according to Ameer Bhaiya's theorem? Yes, you all have understood all the concept. Very good, very good, very great. Now, what we are going to do is, instead of having a hollow sphere, we are going to discuss about a solid sphere. Difference क्या है? What is the difference between a hollow sphere and a solid sphere? The only difference is that the solid sphere will be having inside masses. Okay, there will be an inside mass in the case of a solid sphere. So yes, note it down. Tell me, at a distance of r from the center of a solid sphere, or whether it is a hollow sphere, isn't the equation for force same? G mm by r square divided by mass gm by r square. Matlab, the value of E for an outside point for a solid sphere will also be gm by small r square, and on the surface will be gm by capital R square. It's not a big deal. Everybody knows this, है ना? बोल दे हाँ सर हम सबको पता है. But The only problem here is, or the only difference in the value of E, which is the gravitational field, will come for an inside point. Why? Because in the case of hollow sphere, koi mass nahi tha andar. There was no mass inside. But in the case of solid sphere, do we have mass? Soch, yes, we do have mass. If there is a mass, won't a force be experienced for an internal point? Yes, there will be a force. So won't there be a force per unit mass? Yes, there will be. If there is a force per unit mass, won't there be a gravitational field? Yes, sir, there will be. So it is our duty to find that out. करेगा है ना? और क्या सर? आप है तो हम बिल्कुल करेगा. देख ले. Now our thing is, at a distance of r, which is an inside point, what is the value for E? E for an inside point. E ka formula? Force per unit mass. Okay. Tell me, if I keep a small m here, what will be the force it experiences? Jaldi. G. Can I use the entire mass here? Matlab, if the solid sphere is having a capital mass of m, is the entire mass of m, is it there to give a force on this chotu m? No. We have discussed this concept in yesterday's class when we were discussing acceleration due to gravity. How many of you do remember? Sabko yaad hai? I do think so, right? Okay. Now, dekh le, this chotu mass m is only included by this much of mass. If I use another color, this much. Which means the mass which is contained in this much of volume will only be there to provide a force on this chotu m. Which means in the equation for force, I'll be writing G. If this is m dash into m divided by, what is the distance? Small r square. So the value of force is G m dash m divided by r square, and now I have to substitute for this m dash. I hope everyone knows. I used to say this example in all my classes. How will you find out the mass of 5 kilogram of rice? If you know the mass of a unit kilogram. Similarly, how will you find out the mass of this much of volume? If you know the mass per unit volume. How will you find out mass per unit volume? Mass divided by total volume. Total mass divided by total volume will give you mass per unit volume. Matlab, if I take 1 meter cube of the solid sphere, how much mass is contained? That is mass per unit volume. Tell me, if this is having a volume of V dash, how will I find out the mass contained in this much of volume? Mass per sorry बच्चा लोग, पता नहीं क्या हो गया. So, for finding out the mass which is contained in this chotu volume, you should be knowing the mass per unit volume multiplied by V dash. So, mass per unit volume multiplied by the volume of the space will give you the mass contained in that particular region. है या नहीं? Substitute कर ले. Mass. This is a spherical body and the volume is 4 by 3 pi capital R cube, the total volume. Multiply the volume of that small sphere we have considered. 4 by 3 pi, the small r cube. Cancel kar le. M small r cube divided by capital R cube. है या नहीं? हाँ सर, बिल्कुल. Substitute कर ले इधर. G m dash is equal to m small r cube divided by capital R cube. What is remaining? Small m by this small r square. What is the simplification you can make? G m by r cube by r square, 1r divided by capital R cube. Bas, done. This is the force. And what is the gravitational field? Force per unit mass, F divided by the small m. How much will it be? G m r divided by r cube. Bas. और कुछ नहीं. Okay, so जल्दी बोल दे. Is it clear? In the case of a solid sphere, the value of gravitational field for an outside point, which is gm by r square, and on the surface gm by capital R square, is the same just like a holosphere. The only difference is for what? Yes, for an inside point. For an inside point, the value for gravitational field, which is at a distance of r, formula G, capital M, small r divided by capital R cube. Done? Everyone? Any doubts है तो बोल दे, कोई doubts है तो. म्यारा, संकमित्रा, श्रेया, सबको मनसिलाई. Everybody got it. No doubts? And everybody noted. Saloni, Sis, Myara, Sankamitra, Shreya, then Hariom, hi. Sarav, yes. If the distance is 0, okay, very good. Helish is asking me doubts in between, very good Helish. If the distance is 0, yes, small r ho jayega 0, because small r is the distance measured from the center. Capital R cube for an inside point is a constant, hai na? Yes, the radius of this particular solid sphere is a constant. So the only thing that will be changing for an inside point is chotu r. So once you take the point exactly at the center, chotu ho jayega 0. When the small r is 0, the value of this gravitational field will also be 0. Okay, yes, badhiya, no doubt Sankamitra, very good. So theek hai. So I hope that when you say, sir, no doubts are there, I think it simply means you understood everything, because as you all know, doubts won't be there in two cases, once you understand everything or once you understand nothing. Okay, noted this down. Shall we start doing the questions? Okay. Okay, let us start. If the position of the object A is 0.5 r above the surface of the earth, while the position of the object B is 2 r above the surface of the earth, then what is the ratio of gravitational field that is experienced by A and B? R is the radius of the earth. Let us draw this and understand the concept, then we will proceed by doing the problem. This is our earth, हमारा mother earth, उसका mass है capital M, ठीक है. Now we are having different points A and B. The point A is at a height of 0.5 r. So from the center, how much will it be? R plus 0.5 r. This is point A. Another point B is there and its height is 2 r from the surface. So total distance is equal to r plus 2 r from the center, right? The question is, what is the value for gravitational field? Formula for an outside point, Gm by small r square. G is same, mass of the earth same, so E is inversely proportional to the square of r, which is the distance from the center to the point. Now what is left? Which need to find the answer, bus, hai na? So gravitational field at the point A to gravitational field at the point B, EA by EB, inversely proportional to r square. So EA by EB is equal to RB divided by RA, the whole square. Koi gadbad hai? No problem at all. Now the small simple mistake you all will be making is, or which you all will be having a tendency to make is, you will choose this small r as a distance from the center according to whatever is given in the question. You will say this RB is equal to 2r, okay, and you will say RA is equal to 0.5 r. Once you take that answer, to wrong ho jayega, you will be getting the wrong answer. Okay, so what is small r? You should be knowing it's the distance from the center, isn't it? So RB is the distance to the point B from the center. Kitna? R plus 2r. How much is it? 3r, right? So this is 3r by RA is r plus 0.5 r, that is 1.5 or 3 by 2 r. 1.5 is 3 by 2, I hope everyone knows. 3r cancel, ये 2 तो ऊपर हो जाएगा and 2 square is 4. उत्तर है हमारा पास, और क्या, हमारा पास बिल्कुल उत्तर है ना? So it's option C. हमारा उत्तर है ऑप्शन सी. Everybody noted? Everyone जल्दी बोल दे. हाँ सर, बिल्कुल बिल्कुल. Yes, I can see Devika who gave the option C. Then Shreya, C, yes. Preeti, Shankamitra, C, yes. Then who do we have? Palak, Shreya, Aarti, yes, yes, yes. Very good, very good, very good. Noted along with me, बिल्कुल बढ़िया. Okay, very good, very good. ठीक है. So, before we proceed further, कोई बात नहीं म्यारा, please do watch the replay and understand the concept, okay? If you have understood the concept, then तो great. Okay, very good, very good. Okay. Now, I know that it's been so long, I have made a song for you, है ना? So, मुझे भी थोड़ा वो मन आ रहा है. So, I'll sing 2 lines for you. Obviously, it will be the song you might have listened from me. But still, बहुत दिन हो गया ना? Because nowadays I'll be taking classes from studio. I won't be bringing my guitar. So आज तो सोचा कि हाँ मेरा बच्चा लोगों को एक गाना तो मैं तो बजाएगा. And as you all know, not necessary that it will be good. But let's see, है ना? And let me tell you, the class is not over, okay? We'll be having 20 minutes more class. So I thought I'll be giving you a small a break, bas. शाम सवेरे तेरी यादें आती है, आके दिल को मेरी यूं तड़पाती है. ओ सनम मोहब्बत की कसम, के भी चढ़ना तू दस्तूर हो गया, यादों में तेरी मजबूर हो गया. ओ सनम तेरी यादों की कसम. बसी हो पर दूर हो कहीं, दिल के करीब हो ये मुझको है यकीन. ओ सनम तेरे प्यार की कसम. ओ सनम मोहब्बत की कसम. ओके, सो आई होप आप लोगों को थोड़ा तो ब्रेक मिल गया. राइट? ओके, सो ठीक है. तो आई होप your mind is back to that fresh condition so that you can take in more and more knowledge. Thank you so much, Sujal, Shreya, Harsh, Sankamitra, Saloni, Jatan, okay, Palak, thank you so much, thank you so much. Okay, so I want you all to make me say that my warriors are also awesome. Kaise? Keep on learning in the best way possible, and will you all be promising a very amazing mark for your term 1 examination? How many of you? How many of you can promise me an amazing mark for your upcoming term 1 examination? Jaldi bol de. Yes? Okay. Everyone, it's a promise from Sankamitra, Pathviraj, Palak, Ishrat Firdaus. Thank you, Preeti. Miara, yes. Okay, definitely. Very good. Sachin promised me. Sankamitra, Shreya, level best, Devika. Very good. Yeh chahiye, Saloni, Hellish World, and thank you so much. Right? So I'm expecting from every one of you. I'm putting in all my effort. Right? आप सब लोगों को देखता है. So whatever are the questions gonna come for your board examination and also for JEE mains also, I am putting in the best way possible so that you can come and learn with me. Right? Okay. So ये तो हो गया. ये तो हो गया है ना. ठीक है. हम तो जाएंगे. How many of you can give me an answer to this? Dependency of intensity of gravitational field of Earth. What is Earth actually? Earth, is it a solid sphere or a hollow sphere? A solid sphere or a spherical shell? It's a solid sphere. So you have to use all the formulas of gravitational field that will be used for what? Yes, that will be used for the solid sphere for finding out that for the Earth. ठीक है. Tell me which one is correct. And please make sure that you also will be taking in consideration of the direction, not just the magnitude. How many of you can give me the answer for this? जल्दी बोल दे. जल्दी 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 बोल दे. How many of you can give me an answer for this? It's option B. Thank you, Hardik. अभी तो आंसर बोल दे मुझे. Everybody says option B, but there is a small error in it. I'll tell you. Okay, what is a small error you all have made when you have gone for the option 2? देख ले, अच्छे से देख ले, everybody. Okay, so Earth, it's a solid sphere, ऐसे, है ना? और क्या सर? बिल्कुल. So we have our Earth here. This is our center. Okay, and for an inside point, we all know the formula for E is equal to G m small r divided by r cube. So usually, if you look only into the magnitude of E, and if you start drawing the graph between E, which is the gravitational field, and the distance r, how will it be? For an inside point, E is directly proportional to r. I hope you all can see that. Which means as E increases, r increases till it reaches the surface. At the surface, the value for E is equal to gm divided by r square. It will be gm by r square when you reach it on the surface. So if r has increased and if it is equal to r, it will be gm by r square. ठीक है. Now from the surface, if you again move outwards, formula is gm by small r square. Matlab, as the small r value increases again from the surface, what happens to E? It is inversely proportional to r square. So as r increases, E value will be decreasing ऐसे. Based on this, you would have gone for the question the option 2 as our answer. But this option is wrong. This was a correct graph for E in the case of a solid sphere or Earth if only this graph was given. But one more graph is also given in the negative region, ऐसे and ऐसे. If these two graphs are given, you should be going for the second one, this one with the negative part. Q. Because if these two are there, it simply means not just the magnitude of E is considered, the direction of E is also considered. अरे जल्दी बता, what is the direction of E? Is it positive or negative? अरे देख ले, the value of E is a force experienced by a mass. Force will be toward the center. It will be in the negative direction. है या नहीं? है या नहीं? Yes, it is. So it is so much important to represent E in negative. If these two different graphs are given, if this was the only graph present in the 4 option, you could have gone for this. But these two options are given. If these two are given as 2 different options, then you should be only going for this one. Understood? Kyunki this E is a vector. Once you include the direction, this has to be drawn in the negative part. समझ में आ गया सबको अच्छे से? हाँ, अच्छे से समझ में आ गया, कोई गड़बड़ नहीं, बिल्कुल. तो हम जा रहे हैं, ठीक है. वी आर गोइंग फॉर द नेक्स्ट वन. नेक्स्ट क्वेश्चन, जल्दी 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 जल्दी. संघमित्रा हसन, yes, it's the option A. Very good. So for this, the correct option is A, this one. ये है हमारा करेक्ट ऑप्शन. ओके, बिल्कुल ठीक है, बढ़िया बढ़िया, बिल्कुल बढ़िया. अभी देख ले नेक्स्ट पार्ट. 2 point masses M, can you see? Yes, 2 point masses are M are kept at the 2 vertices of an equilateral triangle of side A as shown in the figure. Question: find magnitude of gravitational field strength at the point O. ये है हमारा O. Okay, what is the value for gravitational field strength? We'll take a different page and do this. देख ले, equilateral triangle. Equilateral triangle, there is a small hint is given so that you can find out the angle. Bus, it's 60 degree. है ना? Okay. You have 2 masses M and this M here. The question is to find out the value of E net at this point. कैसे? This mass will be producing a value for the gravitational field. Formula G M divided by, if this distance is A, square. And what about this mass? It will also be producing a gravitational field at this point. Formula G M by A square, which means the value of E1 and E2 are the same. Let us put it as E with Gm by A square. Magnitude is same. Lekin, is it only concerned about magnitude? No. Why? Because this E, which is our gravitational field, is a vector quantity. Vector has direction. And iska direction kya hai? It will always be an attractive force, so towards it. It will always be an attractive force towards it. So these are the directions and these are the 2 vectors with an angle of 60 degree. 2 vectors making some angle theta, resultant root of A square plus B square 2AB cos theta. So here the resultant value will be equal to, net value of E is equal to root of E1 square, that is E itself, root of E2 square plus 2 E1 into E2, both are E itself, into cos of the angle between them, that is 60 degree. I hope you all have understood why I have written or chosen one value as E. Kyunki the value of gravitational field provided by this mass and this mass magnitude, it's same. है ना? देख ले G small m by square of the distance. It's an equilateral triangle. This is side A. This is also the side A. Now अब कर ले. E square plus E square 2E square. 2E square cos 60 is 1 by 2. ये 2 cancel हो जाएगा, plus E square. ये हो जाएगा 3 square root. So this is root 3 E. है या नहीं? हाँ सर बिल्कुल. So ये हो जाएगा root 3 times E का वैल्यू कितना? अरे G M divided by. This is the net value of the gravitational field, which is root 3 times Gm by A square. Okay, कोई ने दे दिया? कोई ने दे दिया ये? I hope you all have noted this down. Those who are not so fast with your writing, what you can do is take a screenshot and after the class, okay, write down everything in the notebook. ठीक है? So हमारा उत्तर, yes, हमारा उत्तर है option A. बस root 3 Gm by A square. Any doubts? कोई दिक्कत है तो you can put it in the chat box. जल्दी से जल्दी फटाफट. Yes, option A is correct. Very good, very good. Easy PC, PCB master. Very good. So we can have we have Myara, Sonam, Prabhat, Devika, Palak, then Som, Ritima, Palak. Everybody with the correct answer. Very good. Okay, आप भी आंसर दिया था. Very good. So no doubts. ये ऑप्शन इज करेक्ट. यस, वेरी गुड, वेरी गुड. सो कोई दिक्कत नहीं है ना. इजी पीसी लेमन क्विजी. और क्या सर, और क्या. सो shall we do some more question so that this concept of gravitational field will be more and more clear to you. Okay, so अगला question. अरे ये तो डायरेक्ट क्वेश्चन है. This is a very simple and a direct question. What is the intensity of gravitational field at the center of a shell? Shell का not only at the center, for everywhere throughout the inside point, the value of E is. जल्दी बोल दे. What is the answer for this? इसका आंसर क्या है? What is the answer? What is the answer? Answer for an inside point. Intensity of gravitational field, okay, at the center for an inside point. Inside point, सब भूल गया. Is it option A? अरे भूल गया. It's a shell. मतलब there is no mass inside and the value of E here was 0. I told you, no mass to attract another mass. If there is no mass, there is no force. If no force, E value will be 0. अब मिल गया सौरभ. Yes, it is 0. Ritima, very good. Not only at the center, any point you take in a spherical shell, value of E was 0. याद है क्या ये? अरे, we have done this problem. There is no mass. Let's say I keep a mass of small m here. If someone is asking to find out the force experience on the small mass m, how will you find out? It is gmm by r square, but there has to be a mass inside this to attract it. Can you find any mass inside the spherical shell to attract the small mass m? No, nothing is there. So no force will it be experiencing because it's a shell. Inside the shell, no mass is there. No mass, so nothing will be there to give a force on the small mass m, and force per unit mass, which is the gravitational force, will also be 0. है ना? अब तो याद आ गया. ठीक है, अब तो याद आ गया. I think I can see that from the energy in the chat box. बस. So the answer for this is 0, not only at the center, at any point inside the shell. Very important. अभी देखा कि सेंटर पे बोल रहा है. ठीक है. Next, how many questions are left? Okay, so we have one more question. वो भी करेगा. Okay, I think this will be the very last question for today's session. So everyone try to give the correct answer for this. At what distance d, small d, from the surface of a solid sphere of a radius r, field strength is same as at a distance of r by 4 from the center? How many of you understood this problem? It's a bit tricky problem. Okay, it's not a big problem, but still, okay, which means the question is only for 2 lines, but it's thoda tricky hai. Okay, let's explore this and understand what is hidden in this question and how to simply solve this. Read the question once again. At what distance d from the surface of a solid sphere? From the surface, there is a point which is at a distance d of a solid sphere, and the radius of the solid sphere is capital R. Okay, field strength is same as, which means if I mark this point as A, and if I say that the value of gravitational field strength is EA at this point, question is at what point inside which is at a distance of r by 4. Let's say there is a point B and the value for gravitational field is EB there. Okay, the question is what will be the value of D so that the gravitational field at this point and the gravitational field at an inside point which is at a distance of r by 4 will be the same. Question, those who want to understand it once again read. At what distance D from the surface of a solid sphere which is having a radius of capital R, field strength is same, which means the field strength at this point is same as a distance of r by 4 from the center. From the center r by 4 is marked. Okay, now understood. Mark it. EA is equal to EB. Tell me what will be the value for the gravitational field at the point A. Formula Gm divided by small r square. Small r matlab the total distance from the center. How much is it? Till here it is radius plus d. So this is r plus d the whole square. This is an inside point, the point B. Formula Gm small r. Small r is the distance from the center. Those who want me to write the formula here, Gm small r divided by capital R cube for an inside point. Gm small r ka value r by 4 by then cube r cube, put it as r cube itself. हो गया, done. Gm cancel, r cube r cancel, r square will be there. So we'll have 1 plus r by d the whole square is equal to 1 by 4 r square. Sir cube hai, अरे देख ले, one cancellation happened here. Take this to numerator, okay, and take the square root. R plus d is equal to, then don't write 4r, okay. If I take the square root here, take the square root of r square and 4 also, because a common mistake everyone makes is r plus d is equal to 4r. You'll get the wrong answer, है ना? How much is it? कितना होता है? R plus d is equal to root of 4, that is 2r. हो गया. So d is equal to 2r minus r. हो गया तो हो गया, आंसर भी हो गया, मजा भी आ गया. So समझ में आ गया सबको? जल्दी बोल दे. So we have the option B as our answer. कोई भी डाउट है तो जल्दी बोल दे. If you have any doubts, any chotu motu doubt, whatever it is, it's fine, because the next 3 to 4 minutes I'm just giving you for asking the doubts. So I hope this is clear. Yes, Myara, Ritama, Ishrat, yes, Onam, yes, it's option B, isn't it? Yes, it's option B, which is D is equal to R. No doubts. Very good. Okay, Manasilai Saloni, very good. Arey sir, please move. Okay, so done. Ishrat, I hope you can see. No chotu motu doubt. So nobody has any doubts? Doubt time. जल्दी से पूछ ले. हाँ, होमवर्क तो था है ना, we forgot. मैं भी भूल गया. Okay, so I am looking into the, okay, so there we go, no doubts. Okay, B option is correct. Yes, हाँ हाँ मेरा होमवर्क तो नेक्स्ट क्लास ऑनवर्ड्स आई विल ट्राई टू आई विल ब्रिंग. ठीक है, मैं तो भूल गया आज. B option is correct. Okay, time for plus class. My from October 11th onwards, my plus class will be starting, which is the crash course. हाँ, okay, okay, Palak. Okay, so I'm not able to see the doubts from any one of you. So every day when you come to my classes, okay, I'll be giving the last 5 minutes as the doubt session. Sir, in the inner spherical, why will it be 0? Why it has to be 0? The third time I am going to explain the same thing, Ishra, just because you asked me. And my sister's name is also, it is not Ishra, it is Isra. Okay. So anyway, inside, why it is 0? If I take a point here, let me keep a mass m here. Okay. Why it has to be 0? Because E will only be existing, which means the gravitational field will only be existing if there is a force, because E is defined as the force per unit mass. If someone try to find out the force on this small mass m, what will be the basic formula? G capital M small m divided by r square. Matlab, for attracting this mass inside this region, there should be some mass present. है ना? Can you find any mass inside this hollow region for substituting for this capital M to provide an attractive force on the chotu mass? नहीं. समझ में आ गया? So that's the reason. Okay, good. So please explain last one. Last one, there is nothing to explain here. Please look into here, because the question is, they are asking or talking about 2 points. One of the point is at a distance of d from the surface. Another point is an inside point which is at a distance of r/4 from the center. Okay, they are telling that if the value for gravitational field at these 2 points are equal, what should be the value of d? So you just have to equate the value of a gravitational field at these points by substituting their formulas and cancelling off. आपको मिल जाएगा. Miara, yes, I'll be sending it by tonight or something, or by early by tomorrow morning. Okay. Menti, I'll tell you. Okay, which means a potential we'll be taking in our next classes. Then how many of you are aware that we have a class tomorrow, which means we have a special class tomorrow. At 5:30 we have moment of inertia. MOI means moment of inertia from which chapter? Yes, from the chapter of rotational motion. A special class is there. And at 7, this is about tomorrow. Okay, at 7 we have another special class, and it's on the topic of rolling motion. Rolling motion is also a subtopic from rotational motion, and I hope you know that this rotational motion is a bit difficult chapter, and these are the important topics from it. So I thought, okay, let me do a revision for all the students here, so that you can do the term 1 examination in a simple way. Special class tomorrow at these respective times. Those who haven't joined special classes till now, what do you have to do? Go and download the Unacademy learning app. Okay, and after logging in, click on the menu button. On the top you can see special from the pop-up menu, and then let me tell you, it is completely free. Someone will be asking, sir, ye to app pe hai, we have to pay something? No, nothing like that. Okay, it is completely free. They'll be asking for invite code. Those who know me, what is the code? AMB10. So use this code and get 10% off. Sorry. Okay, come to this particular special class entirely for free. Okay, the code is AMB10. These are the topics, and right now those who haven't enrolled, jaldi enroll kar le. Who haven't downloaded the Unacademy learning app, which is completely free, go and download right now. Okay, search for this course and enroll for this. The code once again AMB10. Okay, yes, everyone. And I hope you all know why special classes are important, or why the name special. Because it's special, because we have a chat box which means live chat box will be there. You can ask your questions and doubts in the question tab. Live polls and quizzes will be there. Leaderboard will be there. Everything will be there. Okay, so why PCB Master? Then this was the crash course for term 1 which I was talking about. It is a crash course, which can help you get an amazing mark and crack your term 1 examination for board 11th. Pranjay sir, Anurag sir and me will be taking physics. Pranjay sir will be taking bio. Chemistry will be handled by Vivek sir and Max will be handled by Nikki ma'am. So don't miss your chance. Okay, yes. These are the other batches which is going to start on these respective dates, as you can see. And right now an amazing offer is going on, as you can see. If you make the subscription right now, okay, you'll be getting an extra 4-month CBSE subscription and again extra 4 months of a Creative Corner subscription also you will be getting. And don't forget, for this applying for 10% of discount, which code? Ameer sir ka code, which is AMB10, don't forget. Okay, yes. And thank you so much everyone. Is anyone here who haven't liked the session and who haven't shown some love towards Ameer sir? Okay, if anyone is here, jaldi se jaldi fatafat go and hit the like button and do let me know that you have enjoyed the class, you have understood each and every topic, and you will be coming to the next class by completely revising. My next class will be on next Monday. Okay, some days I won't be there because of some personal reasons, but on Monday we'll be continuing with the topic of gravitational potential, one of the important. Devika, so much. Palak, thank you so much. Yes, I'll be going rushing to have my dinner. Okay, so bye everyone. Thank you so much, PCB, Mohit, Miara, Devika, Palak, everyone in the classroom. Thank you so much for making this class super energetic and super great. So bye everyone. Sujal, Sylvia. Okay, bye. Me signing out with Unacademy, and let's crack it.